Hi friends, now I am explaining what is the definition of infinite series, what is the definition of partial sum, absolute series, positive terms of a series and alternating series today class. So infinite series which is formed by based on a sequence. Already in previous lectures we discussed what is the definition of sequence. So sequence is denoted by Sn. Okay, now definition of an infinite series. If I am taking An is a sequence of real numbers, An is a sequence of real numbers, then the expression, now here An is a sequence of real numbers, the first term is A1, second term is A2 and so on, nth term is An. The expression A1 plus A2 plus and so on, An plus and so on is called, this is called as an infinite series. The infinite series, this infinite series is usually denoted by this notation sigma An. Sigma An, the infinite series usually is denoted by sigma An, or it is also as k is equal to 1 to infinity ak. This is an infinite series, or it also written as summation n is equal to 1 to infinity an. This is the infinite series in which a1 is the first term, a2 is the second term and so on. An is called as nth term, which is also called as general term. General term of series. This An is called as a general term of a series. Now I am discussing partial sums of a series. Partial sums of a series. Partial sums of a series. Suppose I am taking sigma n is equal to 1 to infinity an is equal to a1 plus a2 plus and so on, an plus etc. Is an infinite series. It is an infinite series. Then the sum of first n terms, the sum of first n terms is called, the sum of first n terms is called partial sum of the series sigma an. The sum of first these n terms is called as a partial sum of the series sigma an. That means a1 plus a2 plus a3 plus and so on plus an, this is called as a partial sum of the series sigma an. It can be denoted by Sn. Sn is equal to a1 plus a2 plus a3 plus and so on an. So this is called as a partial sum of the series sigma an. This can be denoted by Sn. Partial sum of the series is denoted by Sn. Sn is equal to a1 plus a2 plus and so on. That means the partial sum of the series is equal to sum of first n terms of a series. That means Sn is equal to this one. So n is equal to 1. For n is equal to 1, then we get S1 a1. S2 means sum of first two terms a1 plus a2. S3 means first three terms, sum of first three terms a1 plus a2 plus a3. In general Sn is equal to, I am writing Sn is equal to a1 plus a2 plus and so on an minus 1 plus an, n terms. So this means what? This can be denoted by Sn minus 1. This can be a1 plus a2 plus up to an minus 1 is denoted by Sn minus 1 because of here S2 2 terms, S3 3 terms and so on. Sn minus 1 means n minus 1 terms a1 plus a2 plus and so on an minus 1. So that it is denoted by Sn minus 1. Nth term is an. Sn is equal to Sn minus 1 plus an. Therefore this implies an is equal to Sn minus Sn minus 1. Sn is equal to an is equal to Sn minus Sn minus 1. This is the relation between Sn and Sn minus 1. Since n is natural number, so Sn is a sequence. Sn is a sequence. Here Sn is partial sum of a series sigma an. Then Sn is called as a sequence. This is called sequence of partial sums of an infinite series sigma an. So Sn is called partial sum of a sequence, partial sum of a series sigma an. The sequence of these partial sums, this is called as a sequence of partial sums of an infinite series Sn. So simply the sequence Sn is called as sequence of partial sums of a series sigma an. To every infinite series sigma an, there corresponds a sequence Sn of partial sums. Sequence of Sn of partial. Every infinite sigma an, there corresponds a sequence Sn of its partial sums. అంటే ప్రతి ఇన్ఫినైట్ సిరీస్కు ఒక పార్షియల్ సమ్ కంపల్సరీ ఎగ్జిస్ట్ అవుతుంది. సో ఎవ్రీ ఇన్ఫినైట్ సిరీస్కు ఒక పార్షియల్ సమ్ ఎగ్జిస్ట్ అవుతుంది. ఆ పార్షియల్ సమ్ కన్వర్జెస్ అయితే అప్పుడు సిరీస్ కన్వర్జెస్ అని చెప్తాము. నౌ ద బిహేవియర్ ఆఫ్ అన్ ఇన్ఫినైట్ సిరీస్. ఇన్ఫినైట్ సిరీస్ యొక్క బిహేవియర్ కన్వర్జెన్సా డైవర్జెన్సా అనేది దేని మీద డిపెండ్ అయ్యింది అంటే సీక్వెన్స్ ఆఫ్ పార్షియల్ సమ్ మీద డిపెండ్ అయింది. సో సిరీస్ కన్వర్జెన్సా డైవర్జెన్సా కావడం అనేది సీక్వెన్స్ ఆఫ్ పార్షియల్ సమ్ మీద ఉంటుంది. An infinite series sigma an converges or diverges according as the sequence Sn of its partial sums converges or diverges. So the series number 1, the series sigma n is equal to 1 to infinity an converges or said to convergent. The series is said to be convergent if the sequence Sn of its partial sum, the sequence Sn of its partial sum convergent. The partial sum is convergent. So if the sequence Sn of its partial sum of a series is convergent, automatically we say that the given series is converges. Means what? If limit n tends to infinity, the limit of the partial sum is equal to some finite value s. Already s means what? Sn means what? a1 plus a2 plus and so on an. It is the partial sum of a sequence Sn. So Sn is called as a partial sum of a sequence. So the limit of this partial sum is equal to some real number. It is a real number. So the sequence of partial sum is converges whenever this is a real number. So sequence of partial sum Sn is converges to real number yes. Hence we say that the given series sigma an is also convergent, and also we write summation n is equal to 1 to infinity an is equal to the finite value s. Friends, the convergence of the series completely depend upon its partial sum of the sequence of a given series. Suppose n is equal to 1 to infinity an is converges if the sequence Sn of its partial sum must be convergent. This partial sum convergence, then only we say that the given series is convergence. That means partial sum convergence means అంటే అర్థం ఏంటి? Sn అంటే a1 plus a2 plus an is called as a partial sum of the sequence Sn. దీనికి లిమిట్ అప్లై చేస్తే ఒక రియల్ నెంబర్ కనుక వస్తే అప్పుడు సీక్వెన్స్ ఆఫ్ పార్షియల్ సమ్ కన్వర్జెంట్ అయింది, అప్పుడు గివెన్ సిరీస్ కూడా కన్వర్జెంట్ అని చెప్తారు. ఇంకోటి ఏంటంటే ఒకవేళ పార్షియల్ సమ్ యొక్క లిమిట్ వాల్యూ కనుక ఎస్ వస్తే ద సమ్ ఆఫ్ ద గివెన్ సిరీస్ ఈజ్ ఈక్వల్ టు సేమ్ ఎస్. ద సమ్ ఆఫ్ ద గివెన్ సిరీస్ మస్ట్ బి ఈక్వల్ టు ఎస్. దట్ మీన్స్ we also written as this also written as summation n is equal to summation limit n tends to infinity, limit n tends to infinity, summation k is equal to 1 to n, k is equal to 1 to n, ak is also equal to s. The meaning of it is also written as n is equal to 1 to infinity, so means n is approaching to infinity, as the limit n tends to infinity, summation, the series can be written as ak, k runs from 1 to n, here n is to infinity, so the meaning of this and this is same. So sum of the series is equal to a finite value s, therefore the given series is convergence. Number two, a series does not converges to real number. Suppose the series sigma an does not converges to a real number s, so we say that this series is diverges. A series does not converges to a real number s, then we say that the series is said to be a diverges. That means what is the meaning of this one? Sigma an is a divergence. Sigma an is diverges if the partial sum of the sequence sn, the partial sum of the sequence sn is diverges. The partial sum of the given series is diverges. The partial sum of the given series is diverges, then series is said to be a divergence. So diverges to, that means what? Whenever it is diverges, limit n tends to infinity, whose partial sum sn is equal to what? a1 plus and so on an. Limit n tends to sn is equal to either plus infinity or limit n tends to infinity, sn is equal to minus infinity. These two cases are said to be diverges. అంటే అర్థం ఏంటి ఇక్కడ? లిమిట్ ఆఫ్ ఏ పార్షియల్ సమ్ కనుక ఫైనైట్ వాల్యూ రాకపోతే ఐదర్ ప్లస్ ఇన్ఫినిటీ కానీ మైనస్ ఇన్ఫినిటీ వస్తే అప్పుడు ఆ సీక్వెన్స్ ఆఫ్ పార్షియల్ సమ్ ఎస్ఎన్ ఏమవుతుంది? ద సీక్వెన్స్ ఆఫ్ పార్షియల్ సమ్ ఆఫ్ ఎస్ఎన్ ఈజ్ డైవర్జెస్. ఎప్పుడైతే ఇది డైవర్జెస్ అయిందో అప్పుడు ఇచ్చిన సిరీస్ కూడా డైవర్జెస్ అవుతుంది. అంటే ఇక్కడ ఏం చెప్పొచ్చు అంటే సిరీస్ కన్వర్జెన్సా డైవర్జెన్సా అనేది దాని యొక్క సీక్వెన్స్ ఆఫ్ పార్షియల్ సమ్ మీద డిపెండ్ అయి ఉన్నది. సీక్వెన్స్ ఆఫ్ పార్షియల్ సమ్ ఎస్ఎన్ కన్వర్జెన్స్ అయితే ఇచ్చిన సిరీస్ కన్వర్జెస్ అవుతుంది. సీక్వెన్స్ ఆఫ్ పార్షియల్ సమ్ ఆఫ్ ఎస్ఎన్ డైవర్జెస్ అయితే ఇచ్చిన సిరీస్ కూడా డైవర్జెస్ అవుతుంది. సో దిస్ ఈజ్ ద కాన్సెప్ట్ ఆఫ్ కన్వర్జెన్స్ అండ్ డైవర్జెన్స్ ఆఫ్ ఏ సీక్వెన్స్. ఇన్ దిస్ కేస్ వీ సే దట్ summation n is equal to either 0 to infinity or 1 to infinity, an is equal to plus infinity provided that limit n tends to infinity, sn is equal to plus infinity. ఒకవేళ కనుక పార్షియల్ సమ్ యొక్క లిమిట్ ప్లస్ ఇన్ఫినిటీ వస్తే అప్పుడు టోటల్ సిరీస్ వాల్యూ ఏమవుతుందంటే లిమిట్ n tends to పార్షియల్ సమ్ యొక్క లిమిట్ కనుక ప్లస్ ఇన్ఫినిటీ వస్తే అప్పుడు సమ్మేషన్ ఆఫ్ గివెన్ సిరీస్ ఇస్ ప్లస్ ఇన్ఫినిటీ. దట్ మీన్స్ ఇట్ ఈస్ డైవర్జెస్. ఇన్ కేస్ పార్షియల్ సమ్ యొక్క లిమిట్ కనుక మైనస్ ఇన్ఫినిటీ వస్తే అంటే లిమిట్ n tends to infinity, sn is equal to మైనస్ ఇన్ఫినిటీ. పార్షియల్ సమ్ లిమిట్ వాల్యూ కనుక మైనస్ ఇన్ఫినిటీ వస్తే అప్పుడు సిరీస్ యొక్క సమ్ వాల్యూ an is equal to minus infinity. Okay, so this is the definitions and behavior of the convergence and divergence of a series. We always concern with the properties of an infinite series rather than their exact values, or where the summation begins. Hence we write sigma an instead of sigma n is equal to 0 to infinity an, or also we can write as summation n is equal to m to infinity an. Okay, now series of partial sums. If all the terms of the series of partial term if all the terms of a series sigma an is equal to a1 plus a2 plus and so on plus an plus etc. are positive. As positive means, that means a1, a2, a3, all the terms of a series are positive, then the series sigma an is said to be a positive term series. Positive term series. Term series. So every term of a series is positive. That series is said to be a positive term series or series of positive terms. Next one is alternating series. Alternating series. It means a series in which the terms are alternatively positive or negative is called as an alternative series. That means suppose a1 minus a2 plus a3 minus a4 plus etc. So like this series is called as a alternative series. Means a series in which terms are alternatively positive or negative is called as alternating series. Suppose I am giving example minus 1 to the power of n minus 1 an. N is equal to 1 to infinity. Look here, the first term n is equal to 1, we get a1. Second term n equal to 2 minus 1 power 2 minus 1 means minus a2. Next plus a3 minus a4, like this. This series is called as a alternating series. The series in which the terms are alternatively positive or negative is called an alternative series. The nth term of this alternate series is minus 1 power n minus 1 into an plus etc. So this is the definition of an alternative series. Next one is absolutely convergent. Absolutely convergent. Absolutely convergent. So the series sigma an, is said to be absolutely convergent. The series sigma an is said to be absolutely convergent if sigma mod an is convergent. Yes, the series sigma an is said to be absolutely convergent if the series sigma n is equal to 1 to infinity mod an is convergent. So this mod of n equal to 1 to infinity series is convergent, then we say that the given series is said to be absolutely convergent. We know that every absolutely convergent is convergent. Every absolutely convergent CGT implies convergent CGT, but converse need not be true. Every convergent series need not be absolutely convergent, but every absolutely convergent series is convergent. So once again I repeat the definition of absolutely convergent. A series sigma n is said to be absolutely convergent if sigma n is equal to 1 to infinity mod an, this series is convergent, then this is called as a absolutely convergent. Discuss the convergence of the following series. Now I am giving some examples for whether the given series is convergent or divergent. Already in sequence chapter we proved whether the given series is convergent or divergent by finding limit of a sequence. If the limit of a sequence is finite, then we say that the sequence is convergent. And also we used many applications or theorems for proving of convergence or divergence of a sequence. In the same manner, here also we are going to prove the series is convergence or divergence, whether it is convergence or divergence. So first I am taking my series is 1 by 1 into 2, 1 by 2 into 3, plus 1 by 3 into 4, plus and so on, 1 by n into n plus 1, plus etc. For this solution, so what is the nth term of the given series? The first term is a1 is 1 by 1 into 2. Second term is 1 by 2 into 3. This is a1, this is a2, this is a3, this is for an. So let the partial sum Sn is equal to a1 plus a2 plus and so on an. This is called as a partial sum of the sequence of given series. For that a1 is 1 by 1 into 2, a2 is 1 by 1 into 2, 2 into 3 plus and so on, an is 1 by n into n plus 1. I am writing this 1 by 1 into 2, 1 by 1 minus 1 by 2. You see here LCM is 2, 2 minus 1 by 2 is nothing but 1 by 1 into 2. So 1 by 1 minus 1 by 2, LCM is 2, 1 minus means 2 minus 1 means 1 by 2. Here 1 by 2 into 3 means 6. I can write this as, without loss of generality, same meaning, 1 by 2 minus 1 by 3. Look here, LCM is 6, 2 into 3 6, 3 minus 2, so 3 minus 2 means what? 1 by 6. Yes, balanced. And so on. Lastly, it can be written as 1 by n minus 1 by n plus 1. 1 by n into n plus 1 can be written as 1 by n into n plus 1 can be written as 1 by n minus 1 by n plus 1. Look here 1 by 1 minus 1 by 2, here minus 1 by 2 plus 1 by 2 get cancelled. Minus 1 by 3, next plus 1 by 3, here get cancelled. Minus 1 by 3 plus 1 by 3 get cancelled. Next here 1 by n, before that 1 by n plus 1, before that 1 by what? Can you imagine the term? 1 by n minus 1 minus 1 by n minus 1 by n minus 2 n minus 1. What the term this is? It's look like. So here 1 by n minus 1, next term is n. 1 by n minus 1 minus 1 by n, because of 1 by 2, 1 by 2 plus 1, like that 1 by n minus 1 minus 1 by n plus 1 by n minus 1 by n plus 1. This will be cancelled. So 1 by n minus 1 before term will be cancelled. Finally we get 1 minus, first term 1 minus 1 by n plus 1. Now taking limit of the sequence. Limit of the sequence. Limit n tends to infinity, Sn is equal to limit n tends to infinity 1 minus 1 by n plus 1. This becomes 1 is constant, limit of constant is constant, minus 1 by infinity plus 1. This is equal to 1 by infinity plus 1 is means infinity. This means 1 by infinity means 0. Therefore 1 minus 0 is equal to 1. So 1 minus 0 is equal to 1 minus 1 by infinity 0, 1 minus 0 is equal to 1. So the limit of this partial sum, limit n tends to infinity Sn is equal to 1. So this partial sum is convergence. So the sequence of partial sum Sn converges to a real number 1. The sequence of partial sum converges to a real number 1. It is finite number. So given series sigma an is also converges 1. So that we can write this as sigma n is equal to 1 to infinity an is equal to 1. Sigma n is equal to 1 to infinity an is equal to 1, or we can write this as summation n is equal to 1 to infinity. What is the nth term of the sequence? 1 by n into n plus 1. 1 by n into n plus 1 is equal to 1. The total value of this series, the total value of this infinite series 1 by n into n plus 1, as n is equal to 1 to infinity value is equal to 1. This 1 means the limit of a partial sum of a given sequence is 1, so that the sum of the original series is also equal to 1. So partial sum of the sequence is converges to 1, given series also converges to 1. So for proving of this result, I can first find partial sum of a sequence of a given series. That is what? Sn కనుక్కున్న తర్వాత ఈ విధంగా సీక్వెన్స్ వస్తుంది. దీన్ని స్ప్లిట్ చేసిన 1 by 1 minus 1 by 2, 1 by 2 into 3 1 by 2 minus 1 by 3 ఇలా రాస్తూ లాస్ట్కు 1 by n minus 1 by n plus 1. మరి దీని బిఫోర్ టర్మ్ ఏముంటుంది? మీరు అబ్జర్వ్ చేసినట్లయితే ఇక్కడ 2 ఉంటే ఇక్కడ 3 ఉంటుంది. అట్లా అప్పుడు ఇక్కడ n minus 1 టర్మ్ ఉంటే ఇక్కడ ఏముండాలి? n ఉండాలి. ఒకటి పెరుగుతుంది. కాబట్టి 1 by n ఈ minus 1 by n రెండు క్యాన్సిల్ అయిపోతుంది. minus 1 by 3 ఇక్కడ plus 1 by 3 క్యాన్సిల్ అవుతుంది. minus 1 by 2 plus 1 by 2 క్యాన్సిల్ అవుతుంది. ఆల్ టర్మ్స్ క్యాన్సిల్ అయిపోయి మనకు ఫస్ట్ టర్మ్ ఇది ఒకటిను లాస్ట్ 1 by n plus 1 పెరుగుతుంది. ఈ పార్షియల్ సమ్కు లిమిట్ అప్లై చేస్తే నాకు వాల్యూ ఏమొచ్చింది? 1 వచ్చింది. 1 అనేది ఫైనైట్ వాల్యూ. సో పార్షియల్ సమ్ ఈజ్ కన్వర్జెస్ టు 1. Partial sum is convergence to 1. That means the sequence of partial sum converges to 1. So given series also converges to 1, and hence we write sum of the given series is equal to 1. Now next problem is show that 1 square plus 2 square plus n square and so on is diverges to plus infinity. That means sigma n square n is equal to 1 to infinity. The given series is n is equal to 1 to infinity sigma n square. That means 1 square plus 2 square plus and so on n square plus etc. Now we want to show that this series is divergent. ఎప్పుడు ఇది డైవర్జెంట్ అవుతుంది? ద పార్షియల్ సమ్ ఆఫ్ ద సీక్వెన్స్ ఆఫ్ గివెన్ సిరీస్ ఇస్ డైవర్జెంట్, ఆటోమేటికల్లీ సిరీస్ ఈజ్ డైవర్జెంట్. అంటే పార్షియల్ సమ్ ఏం కావాలి? లిమిట్ ఆఫ్ ఏ పార్షియల్ సమ్ డైవర్జెస్ కావాలి. లిమిట్ ఆఫ్ ఏ పార్షియల్ సమ్ కనుక్కుంటే అది ఇన్ఫినైట్ వాల్యూ వచ్చితే అప్పుడు సిరీస్ ఏమవుతుంది? డైవర్జెంట్ అవుతుంది. సో దట్ ఫస్ట్ ఐఎమ్ టేకింగ్ ఫస్ట్ టర్మ్ ఈజ్ వాట్? దిస్ ఇస్ a1, ఇట్ ఈజ్ a2, ఇట్ ఈజ్ వాట్? an is so partial sum Sn is equal to a1 plus a2 sum of first n terms is called as a partial sum. So a1 is equal to 1 square, it is 2 square and so on, this is n square. We know that sum of n natural numbers, sum of squares of n natural numbers, n into n plus 1 into 2n plus 1 by 6. Sum of squares of n natural numbers is n into n plus 1 into 2n plus 1 by 6. Already we know that sigma n square, it can be written as sigma n square. Already we have a formula, n into n plus 1 into 2n plus 1 by 6. For that this value is equal to this one. Now I am taking limit n tends to infinity, Sn is equal to limit n tends to infinity. Here n, one more n. I am taking here n common, here one more n common, n into n cube. Then after that we get 1 plus 1 by n. Here already n common, rest of the terms is 2 plus 1 by n by 6 by 6. Okay, then what is the limit value? This means as n tends to infinity cube 1 plus 0, 2 plus 0 by 6, this becomes infinity. So means what is not a finite real number, it is not a finite, means it is infinite quantity. So sequence of partial sum Sn diverges to infinity, it is diverges. Sn diverges to plus infinity. The sequence of partial sum of a given series diverges to infinity, and hence given series is also diverges to plus infinity. The given series also diverges to plus infinity. Yes, therefore the summation of n is equal to 1 to infinity n square can be written as plus infinity. Okay, sir. Sum of these terms is equal to plus infinity. The given series is diverges because of the sequence of partial sums of a given series is diverges. Original series also divergence. So in this lecture we study what is the definition of an infinite series, positive term series, absolutely convergent, alternating series, how the series is converges or diverges. వీటి గురించి మనము స్టడీ చేయడం జరిగింది. థ్యాంక్ యూ ఫర్ వాచింగ్ దిస్ వీడియో.